Welcome in Tectonic Geomorphology. A central question is this: how much do climate factors like rain, temperature, and ice versus tectonic factors like rock uplift and faulting control denudation rates and patterns? Think of it like a balance. Sometimes climate seems heavier, sometimes tectonics dominates. The truth often lies in their interaction. Let's first look at a tectonic control viewpoint. Tectonics builds relief and sets the stage. Without uplift, there is no big mountain for climate to act on. Imagine a simple cross-range slice. Rainfall varies, uplift varies, and we observe erosion. In many active orogens, the highest erosion aligns with where uplift is focused, not with where rainfall is greatest. Uplift sets the pace, and erosion keeps up to balance it on long timescales. Models also show a key limit. If precipitation increases, rivers and slopes erode faster, but long-term erosion cannot exceed uplift, or the range would vanish. Here is erosion as a function of precipitation. It rises with rainfall, but approaches a ceiling set by the uplift rate. As we turn up precipitation, erosion rises, yet it asymptotically approaches the uplift ceiling. In steady state, erosion equals uplift on average. E equals U. Now, the climate control side. In cold climates, glaciers can set an erosional ceiling near the snowline. This is the glacial buzzsaw idea. When peaks rise into the zone of permanent snow and ice, glacial erosion cuts them down. Watch the peak trim down toward the snowline. Now, the climate control side. In cold climates, glaciers can set an erosional ceiling near the snowline. This is the glacial buzzsaw idea. When peaks rise into the zone of permanent snow and ice, glacial erosion cuts them down. Watch the peak trim down toward the snowline. Climate can also drive time-dependent increases in erosion. Consider a region where major tectonic building slowed, yet erosion intensified with the onset of ice ages. Here, the timing points to climate as the driver. Increasingly, we see climate and tectonics are coupled by feedbacks. Tectonics raises mountains, shaping topography. Topography steers climate with orographic effects. Climate drives erosion that removes rock. Removing rock lightens the crust, causing isostatic rebound, and can even focus deformation. The loop continues. So which matters more? It depends on context and timescale. Think of uplift and climate as two inputs feeding erosion. Scenario 1. High uplift, moderate climate. Erosion is high, set mostly by uplift. Scenario 2. Low uplift, extreme climate. Erosion rises, but the uplift limit keeps it from going arbitrarily high. In summary, tectonics provides the energy and baseline, climate provides the tools and tempo, and feedbacks couple them.